Hey everybody, this is Matt. Welcome back for another video. Today we're going to be doing a little bit of a different video than I typically do. I've recently been putting flight simulator videos up on the channel, but this time I was just recently doing some additions to my home engineering lab, and I wanted to share some of the things I found because it's been a little bit of a process, a little trial and error, and I figured I might be able to save some people from some of the work that I did the last few days. So let me switch to what I have here. So I've been in the market for a new oscilloscope. So I've been comparing the Siglent SDS 1202X-E to the ultra budget Hantek DSO2D15. I'm replacing my Hantek 5072P, and the reason for that is some of these newer scopes just have some additional capabilities. Specifically, I was looking at the increased memory depth as well as serial decode capability. So a couple things that I was thinking. First, I figured I'll go with the Hantek because the one that I had so far, even though it's not the best scope in the world, it's ultra budget, and to me it kind of gets the job done on the cheap. I also in the lab have one of these Hantek PC-based scopes, and what I liked about this one was it also adds a weight. First of all, it takes up less space on the desk, but as you can't tell, I've since changed my strategy there. I built up skyscraper style. And then it also has a waveform generator, which is a nice addition to the lab. So that's part of why I went with that. So, yeah, couple things I was thinking. First I pulled the trigger on this one, and then as I started doing some more research, I was starting to find that a lot of people had some things with the memory depth and the serial decode things that they complained about, and that's where I started seeing people preferred the memory depth of this scope. It's a little, it's a small step up in price. It's an extra anywhere between, I think I spent $60 more for this than this. I think it's typically closer to $100 more, but from what I've seen, you get what you pay for there. So let me just, so a couple things that I was looking at when I first started comparing these two. First, I was thinking bandwidth and rise time wise. So I did a bandwidth test. I used the waveform generator here and produced a sine wave, and slowly increased the frequency until I saw a 3 decibel drop in the amplitude of the sine wave produced on these scopes. And basically what I proved there was that these scopes meet the values that they're calling out, the 200 megahertz and the 150 megahertz. Then I started looking at rise time, and what I started to find was the waveform generator here, which the sine wave I think is rated to 75 megahertz, but I think the square wave is rated to, it might be 25 megahertz. Well, what I was finding is I think with any scope I look at, whether it's either of these two or the one I'm replacing here, or even, putting the waveform output here right back into one of the inputs, they were all giving me just about the same, about a 12 nanosecond rise. So I think what I was finding there is it's probably not the scope itself that I was testing. It's probably more I was pushing the limits of the rise time of the waveform generator itself. So I did a little bit of research, and there's a bunch of YouTube videos out there, people building these. This is a Schmidt trigger oscillator, and basically it produces a square wave. It doesn't need to be a particularly fast frequency, but it is a pretty quick pulse for a pretty quick edge. So the edge itself is somewhere on the order of, I was finding with this was a cheapo Amazon non manufacturer, not a reputable manufacturer for this chip. It didn't even show up in an ESD bag from Amazon, and that's kind of what I was expecting. I just wanted something the next day. So that's why I went that route. But anyhow, I was getting about a 3 or 4 nanosecond pulse rise there. So I'll just show you. I'll jump over and just show you here. So that's the waveform I captured with the Siglent. You're seeing about 4.4 nanosecond rise time there. And that's the auto calculated one. So that's going to go from 10% of the, from 10% up to 90% of where it stabilizes off at 5 volts there. So that's quite an improvement from what I was seeing with the output of this. So I think on this scope I saw that 4.4. I think on this one I saw about 6, and then I didn't go back and test that again. So that covers rise time. I'm going to keep jumping forward a little bit here and go through some of these slides. Here's just one more of the pulse edge there. Again, it's showing about a 5 nanosecond rise. That's the output of the edge pulse generator. So this is when I started getting into some of the memory depth and bandwidth memory depth testing of the scopes. So this is a snapshot of the Siglent. I'm trying to remember what I had as an input here. I think this was just a sine wave coming out of the, so 25 megahertz frequency is what it's showing there. Sine wave coming out of the sine wave generator. And what I'm showing is all the way zoomed in on the scope time frame wise at 5 nanoseconds per division. I took the scope out of vector mode and put it in dots mode so that I could see how many samples it's actually taking at that 5 nanosecond time frame. And you're seeing there that the Siglent scope reports accurately that, that's what you're seeing in the top right hand corner there, sampling. So it's still sampling at 1 gigasample per second, but what it's showing you is it's currently taking 70 samples over the course of that period of time. That's where with this scope, the Hantek, all it told me up at the top is it told me it was at, when I was doing the same sine wave test, it was telling me it was 1 gigasample per second, but it still said, I believe it still said 4K points or 8K points. But when I put it in dot mode, it showed me exactly the same thing. It was probably about that same 70 points. That's probably a mathematical formula that they all do 70 points at that level of zoom. So what I found there is it's not like going from one scope to the other I'm going to get any more resolution, in terms of samples at that sort of a time frame. Let me see here. So that covers bandwidth, rise time, memory depth. So another thing that I found testing these two is, so the Hantek, I was never able to get a USB drive to work. One thing that I'd like to be able to do is, plug in the USB stick, take some waveform captures, and then quickly be able to move those over to the computer. Nothing I did here. So I probably could have looked for some software or firmware updates, and maybe something like that would fix that. But it's kind of one of those things of how much time do you want to have to put into your your oscilloscope before you can start testing. I had the same issue with this one. At no point was I ever able to get the USB drive working. At least this one registered me inserting the USB, and I could save scope setup files to the USB drive. This one, it didn't even register that the drive was in there. I think the first time I stuck a USB stick in, it registered it. I power cycled it. So it wouldn't let me save a waveform to it. So at that point, I removed the power. Oh, and I think it locked up the scope. So I power cycled, it froze. So I power cycled the scope, tried reinserting the USB stick, and from that point on, it never worked again. The Siglent, on the other hand, from the first time I put the USB stick in there, it worked just fine. And every time I press the print button, it prints a waveform to the USB drive, and I tested, pulling the stick out, putting it in the computer, and it works just fine. So again, I think you kind of get what you pay for there. So it's another pro for the Siglent. And then, so now I'll get to what's on the screen here. So this is kind of the main thing that I was looking for out of a scope, is I wanted serial decoding capability. So I guess I should say, based on the fact that you see 3 Hantek scopes in the lab right now, I kind of am partial to Hantek. I like getting a lot of value for a little bit of money if it's at all possible. But I do kind of have a point there where I draw the line where, I'm willing to spend a little bit more money to get, additional value if it's going to be a lot more value. So here, yes, the serial decoding works. You see kind of it's bouncing back and forth between two particular packets here. My test setup that I have here, I just have an Arduino running with a simple code that prints hello world out. Prints hello world out to the to the serial port. It waits, a period of time and then prints out UART decode. So here, your first digit there is 55, and then if I run another single sequence, there's a 55 again. There's a 60. That's a 55 again. Of course, it's luck of the draw here. And there we go. There's a 48. So there's the other packet. You can see the same thing up here. We're bouncing back and forth between 55 to 48 for that first word there. So they both do what they're what I want them to do there. The big thing that I'm finding here, so you can see my time frame here is at 1 millisecond. So that's the period of time it takes me to send one of these packets. And again, it's bouncing between the two, right? So if I put the scope back in run mode, I think it is it 500 milliseconds I'm waiting between packets per the waiting 500 milliseconds between packets. So if I so here I'm zoomed out to 100 milliseconds, so I'm sending a few packets there. If I stop that and now try to, oops, did it stop? Yeah. And now try to zoom in, what you're finding there is the decode is it's not able to decode anymore because we weren't able to capture with enough points. I'm going to do that one more time. I'm going to zoom out to, I was at 100 milliseconds, and I'm just going to make, so I was going to try going to acquire and then put the memory depth back down to 8, because if I do that and stop it and now zoom back in, now we got lots of detail there, right? So we'd be able to decode, but the problem is if I hit decode, it doesn't actually decode anything until I run the scope, take it out of stop mode and put it back into run mode. Now all of a sudden it starts decoding, but as soon as I did that, it goes back to 4 kilopoints. So trying to use the decode function. So now that I'm in decode, if I go back to acquire and then go back to memory depth, so it's tough to tell by the video, but everything else is grayed out. It won't let me choose anything other than 4K there. So basically, if I want to be able to capture a longer period of time and see a bunch of different packets sent, I don't have the ability to do that with the Hantek scope. I can look at a packet, I can look at a couple packets, but really my packet length here, if there's any period of time between packets, you kind of lose the ability to do that. The other thing here is when you look at some of the decode options, baud rate 9600, label position just allows you to move up and down where the UART label here down at the bottom is. If I go to the next screen, so I can set the parity, I can set the data bits anywhere between 5 and 8, and then you do have this sync decode where you can either see the monitor, see it synced down at the bottom, which is what we were looking at before. Okay, come on. Or you could put it in this monitor mode, which is kind of cool. But it kind of cycles on its own there. It just you see the numbers cycling, and of course I could put it in single sequence mode and slow it down there, but I don't have the ability to select or anything like that and purposefully toggle through those. Another thing is your only option there for your data format for the output is hex, like you see there. So I'll jump over to the Siglent now. So that's some of the improvements you see up here. So you got hex there. So I guess before I get into some of the cool part, I'll zoom way out here. So let's zoom out to 100 milliseconds like we did with the last scope, and we'll put it in single shot mode there, and it acquires that. So before I move on, actually, I'm going to take one more. So I'm going to run this back out to 100 milliseconds. I'm going to stop it there. So you do have the ability to press the horizontal time button. Thought it was that. Yeah, there it goes. And you get windowed mode here, which is always cool. But again, if you zoom in, because we're trying to run the decode. Oh, I should have. So there's two things going on. First of all, our resolution sucks again. But the bigger thing is, so if I'm running decode, come on decode, where are you going? I don't know why it's not showing me the decode now. So is that a glitch we're watching live here? I don't think that's happened to me all day, but... So I bet you if I zoom in and now do decode, yeah, so that's going to work now. So it can be a little finicky, I guess. So if I back up to 100 milliseconds again. Oh, so I guess I lose the ability to even keep it in decode mode at that. It looks like we'll try to single seek, because I thought it let us do it before. Yeah, if I start zooming back in. So first of all, we lost decode mode, and then the other thing is, so let's start at 20, because I think it allows me to do decode at 20. Okay, so now it's decoding. I'm going to save that. But if I try to put it in window mode, you're going to see a message on the screen that says, dual window mode isn't supported while decoding. So that's kind of a bummer. It's not the end of the world, but it's nice to use window mode. Versus this scope, yeah, window mode works as well as some high memory depth while you're trying to do your decode. So we have it in decode mode here. We got decode going. You can see the decoded values down at the bottom. So now if I start zooming in, so there's our message there, starting with 55, ending with 21. I can zoom out, and because of the nice memory depth, we can scroll to the right. So that message was 55. Now we're expecting this one, I think is 48. Yeah. So, and we get, nice square corners on all of these, even though we took it while zoomed out. So if I zoom back out to 100, and if I recenter ourselves again, but now press the horizontal, that puts us in window mode. And now if I want to operate this way, to see what's going on at a high level while I'm zoomed in, I can. So now I can zoom back out of that and move ourselves over to the next one. The scope is a little bit slower when you try to, just response time is slower when you try to operate in window mode. It's probably a little much for the processor. But if you need this kind of high level view while you're trying to zoom in and decode, you have it available to you, which I like. Another nice thing about this, so I'm in the decode menus here, and in format here, I have the option to choose binary, decimal, or I can put it in ASCII. And that's cool because now you can see exactly what I told the Arduino program to print out, hello world. And then if we take it out of window mode and zoom in on this one again, there's our there's our other message, UART decode. So for serial decoding, and that was that was at 100 milliseconds. One more thing I'll show I had tried and was pretty impressed by this. If I zoom all the way out to 1 second and do a single shot mode, so it says slow acquisition, so it takes a little bit of time to record all of the data. But, you know, if you did need to do a test where you needed a lot, you know, a full second worth of packets, you still have the ability to zoom way in on this, and you still have nice sharp edges, and it still has no problem decoding the values. So the memory depth of this scope for, you know, a $300 scope, I think is awesome. And I think that right there is what makes this scope worth the extra $50 to $100 over the Hantek. A couple more things I wanted to touch on. I'm just reading my notes here. Oh, so this, so I did want to show the list here on this scope. So if I go to display, I can show the list for Decode 1. So now you can see, oops. So let's go Decode 1, select that, and now if I go to scroll, I'm trying to record this video with a phone camera, and it's not working out so well. So you can either scroll up one digit at a time here, or you can punch in. I think it's punch in. Yeah, there we go. And I can pan myself over to line number 1, and then if I hit OK, it jumps me all the way up to line number 1, so I can just scroll through my values. I don't know what that stuff was, but there you can see my UART decode, and there's the hello world, and then it goes back to UART decode. And I'm able to scroll down, you know, I'm at you know, byte 70, byte 80. So I mean, you're able to get a whole lot of data there. So if you're sending long packets with periods of time between packets, this is the scope you want if you're trying to decide between these two. Things that I don't like about this scope is this whole serial thing. I learned the hard way today after putting a few hours into trying to troubleshoot what the heck was going on. I tried troubleshooting with my own probes that came with the Hantek scope, or ones that I had bought independently, versus testing with the ones that came with the Siglent. No difference in using one probe versus another. So basically I should start by saying it was not decoding anything. The Hantek decoded right out of the box and was giving me the hex values just like you would want to see them. This scope was giving me nothing at all. Finally, I got to the point after trying a whole bunch of different things and looking things up on Google, and not really, you know, I only put a little bit of time into looking things up, but I didn't find anything right off the bat. What I ended up finding is, you know, I just had some suspicions. So first of all, instead of writing "Hello World" out, I ended up just writing just a single character. I just printed H, and as soon as I did that, the scope decoded it just fine. So what it told me is it's able to decode one character, but if I tried to print out HE, all of a sudden it didn't decode either character anymore. So you know, that's telling me that the issue is, let's see if I can figure out how to go back here. So I'm in my decode menu. If I go to configure, so you got a baud rate of 9600, and I tried it at multiple baud rates. It did the same thing. At, you know, this scope was able to do 9600, 115 200, 19 200. This scope wasn't able to do any you know, baud rate at all. It didn't matter. I tried playing with the data lengths. I tried playing with the parity, stop bits. So you don't have an option of a stop bit of 0 on this scope. That's one thing I don't like. This scope, you got you do have the option. I don't remember what your options are. Oh no, you don't have an option. So you have no. So you have a parity option. You don't have a stop bit option. So I guess your only option is 0 stop bits, or maybe it's one. It's probably 1. I think that's a default, right, for UART. But the fact that I didn't have a 0 meant I couldn't try it. I had a feeling that maybe trying stop bit of 0 would have worked, but because I couldn't try it, finally I figured out, what if I change the stop bit over here to, that's serial 8, that's 8 bits, no parity, 2 stop bits. And notice I have 1 stop bit here, and it decodes like a dream. If I change the stop bit, so again, I'll bring up decode. It decodes like a dream, and then if I change the stop bits to 2, it's going to go to hell. I got to take it out of, I'll put it back into normal mode. So that's what I was seeing for hours. And I'm trying to figure out why the bigger money scope, is not decoding. And one thing that I had found is there was... if you go to their website, there's a whole bunch of firmware upgrades. So I found that the firmware version that came with my scope was 1.3.17, which was released in 2018. So I tried upgrading to this one, which was, 1.3.27, which was released back in 2023. But even doing that didn't solve my problem. It wasn't. And if you go and look at their release notes, they specifically mention fix the bug of UART decoder with some special settings. Well, their special settings didn't work because there's still an issue. So if you tell, if you tell your if you tell your program here to put out 2 stop bits, and then you set the stop bits here to now, sure, is it possible that my issue is with the Arduino? Yeah, I guess that's possible, but I don't know. I kind of doubt it. I feel like there's a whole lot of people using Arduino, and I feel like it's a lot more people than are using this specific model of scope. So I think Siglent need to go in there and do another update to their special settings for the UART. So if they fix that stop bit issue, now again, zoom out here. Yeah, now it's back to decoding like it's supposed to. And I guess I'll close it out with so that's what I was seeing all day. More of that, and I was playing with all kinds of scope settings, trying to figure out, is it a noise issue? Is it a sampling thing? So I guess by me scrolling through, so here's the here's the firmware update file. In order to do your firmware update, you can download it right from their website. And then these are some of the scope shots I took of everything working just fine, and so that's where we're at now. So moral of the story, 30 minutes into the video, is I'm going to be keeping the Siglent. Like I said, I pulled the trigger on the Hantek first, and it was only a day or two later that I kind of decided, it looks like from what I'm seeing in videos, there's no real detailed, there's a few videos on the decode function, but I feel like it's kind of a niche thing that a lot of people aren't using. So I'm hoping this is helpful to people that, if you're looking for a, higher memory depth for serial decoding, could I just use a logic analyzer? Sure, but I feel like I'm better protected from, voltage transients and that sort of stuff if I just stick with I shouldn't say voltage transients, I should say TTL versus, 5 volt stuff versus other stuff. I feel like it's nicer to have the capability of using a scope, plus you get that, higher bandwidth that you might not necessarily, or the higher sampling rate that you might not necessarily get out of your logic analyzer. So anyhow, hope this is helpful for you guys. I will see you in the next video. Yeah. Bye.